All of you can see my screen. I'm audible. So we have to start the discussion on the barometer. Uh, so we have seen that, right? If I just give a very quick review of what we have discussed. So we have discussed the types of pressure, that is absolute pressure, atmospheric pressure, and gauge pressure, right? And here, moreover, we have also discussed that positive gauge pressure, the gauge pressure can be positive, that can be negative, but absolute pressure can never be negative, right? So on the basis of that, we will discuss about the concept of barometer. Just note down barometer concept. Now, in this barometer, what is the purpose of the barometer? It is used to measure the atmospheric pressure, right? A normal atmospheric pressure. Right now, you are sitting in a room, so you are surrounded by the atmospheric air, right? So, atmospheric air is exerting some kind of pressure, not only on you, but on the walls of the room or whatever the instrument or object is there in the room. They are exerting the pressure. That pressure will be called as atmospheric pressure, right? Here, how the barometer is working, that is what we have to see. Now, guys, so whenever a tube is there, right, the tube which is having a diameter more than 10 mm, right here, whatever the diameter of the tube is there, we are taking it to be more than 10 mm. Now, why we are taking the diameter more than 10 mm, this tube diameter more than that, so that we can avoid, the capillary actions or whatever the capillary effect is there, right? Because whenever you try to dip the any tube inside the mercury or any water column or maybe in a water bath, definitely what is going to be there, uh, there will be something, fluid will rise in that tube or fluid may fall, right, inside the particular tube. Now, I'm not discussing right now the capillary action and all, because that is not required for the gate aerospace. So, what I'm suggesting you, when you keep a very small diameter tube and when you just place it, what you call here in the bath, what will happen in a bucket? When you place it, what will happen? Either liquid will rise in that tube or liquid will fall down from that tube, right? That depends on the nature of the liquid in which you are inserting this tube, whether it is a mercury or it is a water, right? Now, here, to avoid that capillary action and surface tension effect, we should keep it the diameter of the tube more than 10 mm, so that the reading problem will not be there, right? In calculation of the height, there will not be any problem. Otherwise, what will happen? It will keep on fluctuating. If the diameter of the tube is very, very less, the sometimes the liquid will rise like this, or maybe the liquid shape will be like this, and we may not be able to measure accurately what should be the height of that, right? So to avoid that confusion, we keep the diameter of the tube more than 10 mm. Now, you know that the surface, I'll be considering onto the surface 2 points A and B, both are on the same level. The point A and point B are on the same horizontal level, yes or no, guys? So can I say pressure at A will be equal to pressure at B? Just check it out. Can we say pressure at A equal to pressure at B? We can say very comfortably, we can say that, right? Now, when pressure at A point and pressure at B point is exactly the same, so what we can write? At A, what is the pressure which is acting? Can we say atmospheric pressure? PATM that is acting. And what is the pressure at B? Everyone know that whenever any liquid is there, any liquid is there which is having some height h, and at this point, if I want to calculate pressure, what is the pressure value? Rho gh. Can we write like that? Tell me this. We can comfortably write whatever the liquid height is there. Based on the liquid height, the pressure at point B will be rho gh, and the same value I'm writing over here. But apart from rho gh, you have some other pressure also, right? Because here, my dear friend, in the barometer tube, there will be some vapor pressure will also be there. Getting my point? The bubbles of the liquid, even though that is a very very vacuum, right? But still you will be having a little bit amount of bubble. Then what will happen? It will exert some vapor pressure. What is that? PV, vapor pressure. That will also be accounted, right? Now you only tell me if I want to measure my atmospheric pressure, right? I can able to measure that. But who is creating the trouble for me in measuring the atmospheric pressure? Whenever I want to measure any atmospheric pressure, I will just take the tube and I will insert in what we call mercury bath, and whatever the liquid will rise, that height I will multiply with the rho g. I will be directly getting the atmospheric pressure. But who is creating the trouble for me? PV value. Yes or no, guys? Whatever the PV value is there, that is what creating trouble for me. Yes or no, guys? So now tell me, if at all I want to measure directly P atmosphere directly by the reading of rho gh, then what we can write? Simply PV has to be very very small. PV value has to be very very small. For that purpose only, my dear friend, we use it. Always remember, in a barometer we use it mercury as a fluid. Getting my point? Because it is very very low volatile in nature, it exert a very very low vapor pressure. It exert a very very low vapor pressure, right? Because here we might be having mercury vapor, a very less quantity, but still it will be there, right? But whatever the mercury vapor pressure is there, that is a very 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 small, right? For that purpose only we use it. So use of mercury, because the first reason is, my dear friend, mercury is having a very low vapor pressure. If you use water, slightly higher PV value, right? So the in the again reading problem will be there, right? Atmospheric pressure reading problem. Second one, high density. Now what is the benefit of having the high density fluid? See guys, h is nothing but h of the tube. Can I say h is approximately height of the liquid which is being raised in that tube? Or can I say directly that it is nothing but the height of the tube indirectly? So my dear friend, if I neglect the PV value, very very small, then P ATM will be rho GH. Then what is the height of the tube that is going to be required? P ATM by rho G. To measure one atmospheric pressure, if rho G value will be very very high, I will be required very less height of the tube. Otherwise, what will happen? If you use the water, rho value as compared to the mercury is 13.6 times what? The mercury density is what? 13.6 times more than the water density. The water density will be very very low as compared to the mercury density. What will happen? You will be required height of the tube very very large. You may require height of the tube approximately height of the building. That much of height of the barometer you may require to measure the atmospheric pressure. And again, that is not feasible, right? Because as we use height of the, if I increase the height of the what we call tube, then definitely chances of getting damage will be very very high, right? So make a note of it. So that's why you always see in a barometer the mercury fluid is there. So at the A point, there will be some atmospheric pressure that is going to be acting. In a same basically measurement of atmospheric pressure, we use it what we call barometer. Now if I want to measure any pressure, then what we use sometime other instrument also, not atmospheric pressure. But if I want to use moderate, if I want to measure the moderate pressure, I can use piezometer, right? Now what is the piezometer? Let's discuss about that. So anyone know about the piezometer? Tell me guys, what is exactly the purpose of piezometer? Have you seen anywhere or some practical experience? Tell me guys, piezometer. Now all of you have noted down this thing. Can I move to the next segment? Yeah, correct. Correct. So in our next continuation, we will take the second instrument, that is a piezometer. Piezometer, right? Piezometer, my dear friend, it is used for measurement of, or we can write, it is a single vertical tube. It is a single vertical tube. We also use it along with the pitot tube, to measure the velocity of the fluid in a particular pipe. If we don't have pitot static tube, if we are using only pitot tube, in that case also we use it. Getting my point? Piezometer. Why we are using? To measure the static pressure, because whatever the pitot tube is there, that pitot tube is directly giving me the reading of stagnation pressure. That is not giving me the directly the value of velocity, right? For measuring the velocity I need the dynamic pressure, and for measuring the dynamic pressure I need the stagnation pressure minus static pressure. And from where we are getting the static pressure? From piezometer, right? So it is a single vertical tube. You will see the application of piezometer in fluid dynamics also. So it is a single vertical tube where one end of the tube is open to atmosphere, and end is connected to second end is connected to the place where pressure is to be measured. That means, if I say in a diagram particular statement, if I just say that whatever the statement I have written through diagram, then what we can write? There is a tube and there is a tank, for example. There is a pipe, right? So I'm just showing you the cross section of that, or maybe side view of the pipe flow. So whatever the liquid is there, I just want to measure directly the what is the total pressure of that liquid, right? Then directly what we can write? We are inserting the tube, and directly the liquid will rise in that, and whatever the height of the liquid will rise, that will give me the values of pressure at A. Let's say the height we are measuring from the center point, so from here. So if I want to measure pressure at A point, directly we can write rho gh. Now tell me guys, whether this is giving me the gauge pressure or absolute pressure. Rho gh, whatever the pressure value is there, that will give me the gauge pressure. If I want to measure the absolute pressure, for that purpose what we can write? Pa. If I want to measure absolute pressure, then we can write rho gh plus, that we have to add PATM. So this type will give me total what? Absolute pressure, right? Because that when the tube is open to the atmosphere, there will be some PATM will also be acting, right? So make a note of it. Now, but what is the trouble in that? What is the drawback of this piezometer? If let's say the liquid is not flowing, or the liquid is not there in a particular tube, we have the gas, then what will happen? Some of the gases may escape, may start avoiding this tube, and they will be start flowing something like this. In that case, reading we cannot take exactly. The height value may fluctuate. So for that purpose, my dear friend, piezometer, you just make a note of it. It is used to measure. It is used to measure the pressure of, or we can also write Correct. That is what we used to measure moderate positive pressure, positive pressure, moderate positive pressure of liquids only. Right. So make a note of it. And again, yeah, as you rightly said, what he said, he exactly pinpointed that why we cannot use it for the higher pressure, because for the higher pressure you require the higher tube height. Again, that is a trouble for us to get that high height of the particular tube in reality. So if you want to measure the high pressure, if you want to measure the gas pressure, then definitely we have some other instrument, that is a manometer. Again, in the manometer, we have different types. That is a simple manometer, differential manometer, inverted differential manometer, right? For measuring the negative gauge pressure. So for all those purposes, we have the instrument called manometer. Now, all of you have noted down. Can I move to the next one? Now try understanding the next, whatever the instrument we have, that is nothing but we call that to be manometer. It is commonly used to measure the small and moderate pressure differences. This is a simple manometer. What you are observing right now, it is a simple manometer. Simple manometer. So now if I want to measure the gas pressure directly, how we can measure? Just insert the tube, just like a U tube, you know, U-shaped tube is there, and we insert one end of the tube to the pipe where I want to measure the pressure. So due to the whatever the value is there, whatever the pressure value is there, that pressure value will be reflected by the height of the tube which is being raised in the other limbs, right? This is the limbs, other limbs. Now, how we can measure the pressure, my dear friend? Again, that is a very simple task. What we have to do, we have to just take point number one and point number two. Point number one and point number two, they are what? On the same level. Point number one and point number two, they are on the what? Same level. So what we can write? P1, that is equal to P2, right? So what is the value of the P1? P1 is nothing but the what? Gas pressure. And what is the P2 value? P2 value is nothing but, suppose this is a manometric fluid, right? So what we can write? Rho m into G into H. Again, that will give me the what? Gauge pressure. That will give me the gauge pressure. If I want to measure the absolute pressure, directly I need to use rho mgh plus P atm. Right side, I need to add the P atm to get the P absolute value. Make a note of it. Sometimes the two limbs of the tube are connected to the two sides of the whatever we call tanks, right? Two tanks are there, and I need to measure the pressure difference between the two tanks, or what we call two tubes, P1 and P2. And if I want to measure the pressure differences, for that purpose I need to connect one end of the limbs to the other tube also, where P2 is there, some other gases are there. For that purpose we cannot use this simple manometer, we have to use differential manometer, right? I'm just removing this part. Other application of the what we call simple manometer or differential manometer is what? Where we use it? Tell me, guys. In venturimeter we use it, right? Can we use to measure the velocity of the fluid in a particular pipe? Yes, we can use it along with the pitot tube. Again we can use it there also. I will show you the differential manometer, right? How we can use in the case of pitot static probe, right? No, Ravi Teja, try understanding. If I want to measure the gauge pressure, right, so directly the rho gm whatever the rho gh value is there, that will give me the value. But if I want to measure total pressure, because you know that I told you, right, if you see the diagram, that is a very much clear from the diagram itself. There should not be any confusion if I show you once again. See here, see gauge pressure, we know that rho gh. But if I want to measure total absolute pressure, I need to add PATM. There should not be any confusion, right? Now the gauge pressure can be negative, can be positive, but the total pressure, that has to be positive at least. If it is zero, but more than zero, it has to be positive. Let's say in the worst case, it can be zero, but again, it cannot be negative. Now, all of you have noted down this thing.
Sir, hello.
Can I move to the next segment?
Sir, excuse me, sir.
Done.
Hello. Hello. Hello.
Is it done for all? Tell me guys. Can I move to the next segment?
Hello. Hello. Sir.
Now, try understanding,
Hello.
guys, a differential manometer or YouTube manometer. A YouTube manometer. Differential manometer. Yeah. What is the doubt?
Hello. Am I audible,
A
sir?
differential manometer.
Hello.
Hello.
Yes, sir. Am I audible?
Yeah. Yeah. Audible. Yeah. Yeah.
Sir, can you go to the previous slide, sir?
Yeah.
Yes, sir. The pressure exerted by the gas at a point one will be equal to the total pressure exerted by the atmosphere as well as the liquid, no, sir, at a 2.2.
Yeah. That is what rho m liquid is, right? Rho m g
No,
into
sir.
h. This height. Left
So it
one.
will be
This
equal to
one.
the, yes, sir, it will be equal to the total pressure exerted by the atmosphere as well as liquid rho m, no, sir. That means at a point two it will be so like PATM plus में rho GH, no?
Yeah. That is what
That will equal.
P PATM is there plus rho g. That is what I have
Yes, sir.
written. If I want to measure total absolute pressure, this height we have neglected. We are thinking that it is directly connected, right?
So, sir, whatever pressure it will exerted by the gas, no, equal to the total atmosphere plus में rho GH, no, sir.
Yeah, that is what it will be there. But if you just take it zero, for example, then directly you are measuring the absolute pressure as equal to what? Gauge pressure only, right? Getting my point? What I'm saying? If you take atmospheric pressure to be zero, then directly it will give me the value of gauge pressure only, right?
So, sir, if I assume the atmospheric pressure will be zero, then sir height will be increased, no, sir. In that case, height will
Why?
be increased,
Why?
no,
Why height will increase?
sir, because there will be a difference. That means sir, pressure exerted by the atmosphere
Hmm.
at the above surface of the liquid, yeah, liquid, sir, and
Hmm.
plus rho GH will
See,
be
see,
equal to the pressure at the
density of
one,
the
sir.
whatever the we are taking the manometric fluid, we always take for measuring the positive pressure, mercury one. Even though high amount of pressure you are applying, but hardly any changes will be there in the column of the liquid because high density. Getting your point? Low pressure or high pressure, atmospheric pressure will not affect that mercury height in the tube. That much of fluctuation is not there, right? That's why we use manometer fluid as a mercury fluid, so that reading will be stable, right? Getting my point, right? Now, note down the differential manometer. So, differential manometer, for example, there is a pipe, and we have the pipe. Let's say the 2 points is being connected here, point number 1 and point number 2. And if I want to measure the pressure differences between 1 and 2, so we will connect what we call manometer. Again, we will make a hole here. We will make a hole and we will try to measure. We will place the manometric fluid. If pressure 1 is very, very high, they will exert some kind of pressure onto that. And the right side, whatever the manometric fluid is there, it will rise to right side particular limb with the height of x. And let's say for height, this from 2 point to this will be y. For example, I'm assuming. No, in that case, see, that depends on the value, you know, the value which you are calculating. Height of the tube, whatever the value they will be given to you, the height of the tube, based on that rho gh value plus PATM, that is 101.325 kilopascal, right? So that will be basically the things will be there. No, P gas, no, I'm not understanding. P gas, how can you write? No. P gas, absolute, we are writing P of rho gm, rho gh plus PATM, right? That is a very simple calculation. Do not confuse, guys. Pressure at gas is very, very high. Remember, gas pressure is very, very high than PATM. That's why it is this liquid is pushing this one, what we call manometric fluid, to the right side, and that's why the right side liquid is rising, right? Now, so here what you are observing, that if you just apply the manometric principle, the manometric by the manometric principle, what you can have, yeah, that P value is equal to rho gh will give you the gauge pressure value, not an absolute one, right? Now, from the manometric principle, we have to measure the pressure value, right? Pressure at point number 1 and point number 2, both are being the same level, will be same. Both the actually we have to take the measurement from the datum, but both are same. Both the sides, we have the same liquid, that will cancel out. So that's why we are taking point number 1 and point number 2. Getting a point? So here, let's say the density of the fluid which is there is nothing but rho. What is there? Rho. This liquid is what? Rho, which is having the height that we will take. So both the points 1 and 2 are on the same level. Are on the same level. So what we can write? So what we can write, guys? What is the pressure at 1? Can I write pressure at point number 1 will be P1 plus what? Or we can take this to be A and B point. Let me take A and B point. So pressure at A, that is equal to pressure at B. A and B are on the same level. So P1 value plus what about this height? Imagine this height would be same. Here, this would be same. So let's say the height will be what? That we are neglecting, right? Because they will cancel out. They will cancel out. So what is this height? What is this particular height, my dear friend? Tell me, guys. Can I say the total height from here to here will be? Can I say directly x plus y? So rho 1, let's say rho 1 g x plus y can be write directly equal to what? P2 plus what we can write? Rho gy plus rho of manometric fluid, let's say rho m g into small x. Whatever the height of the manometric fluid which is being raised, see, these are the liquid which is there, because anyway the liquid will be what? Rho 1 only, right? So what we can write from here? This P1 plus rho 1 g into x plus rho 1 g into y, that is P2, plus rho g y plus rho m g into x. So this will cancel out. Ultimately, P1 minus P2 will be rho m g into x minus rho 1 g into x. Check it out. Getting my point? What is the total pressure which is being exerted? P1 pressure plus height of the liquid is what? Rho 1 g into x plus y. That is equal to P2 pressure plus height of the liquid. Height of the liquid is what? Rho g y till this here, rho 1 liquid is there. After that, rho m is there. Getting my point? Understanding what I'm saying? Try understanding. At the whatever the level of the liquid is there at A and B, both are on the same level, right? So whatever the pressure in the left limb, that has to be pressure on the what? Right limb. Getting my point? Let me repeat that. Let me repeat. See, so pressure at point number A will be what? P1. That is the pressure which is being exerted by the fluid at the point number one in a pipe. That is the P1 pressure. Plus, what is the height of the liquid? Tell me, guys. You know that whenever I will be moving, or suppose I will avoid your confusions, no need to panic at all. You forget this thing. You forget this particular concept. You forget whatever I told you, dou p by dou x equal to 0. Now, I told you in the last class, P is what? Rho gh. Whenever you are moving in the downward direction, pressure is increasing or decreasing? You only first tell me. Pressure is increasing or decreasing? Pressure is increasing or decreasing? Pressure is increasing. Everyone know that. Now, so P1, I'm moving in the downward directions. So I need to add it or I need to subtract it. Tell me. You only tell me. If I will be moving in the downward directions, so I need to take P1 only. Plus, apart from that, I will be moving in downward direction. So definitely I need to add it. And what I need to add? Rho gh. What rho gh? Rho 1 g into what is the total height? X plus y. Further, I am moving downwards. Let's say this height is what? Z. Let's say, see, to avoid your confusion, I'm telling you a very long method. Once again, do not confuse, sir. You are telling so many methods. No, I'm telling you, you will be end up getting same equation, but be patient. See, you are moving in the downward directions. So you are adding P1 plus rho 1 g into whatever it is coming in your path in moving downward directions. You keep on adding. You keep on adding. What is that? Rho m g z, because you are moving further down. Now what you are doing, you are moving like this, because horizontal will not create any trouble for me. Once again, you are moving in the upward directions. Upward direction, you only tell me what should I write. I should subtract it or I should add it. Minus rho m g into z, because we are moving in the upward direction. Upward direction means what? Pressure has to decrease. By what amount it has to decrease? By rho m g into z amount it has to decrease. Further, we are moving in the upward directions. Upward directions, rho m into g into what? What? X. Further, we are moving in the upward directions, my dear friend. What is coming? Okay, this rho 1 is coming. So I will write rho 1 g into what? Y. And that is equal to what? P2. Check it out. Is that clear, all of you? Whether manometric, whatever the equation we have written, that is clear. You keep on moving like this, you keep on traveling like this, right? And you know that pressure is increasing in the downward directions and pressure is decreasing in the upward directions, right? Or you don't travel at all, you avoid traveling. A very simple method is there. Both the heights, pressure at A and pressure at B, both are on the same level. You try to equate the pressure at both the limbs. What is that? Ultimately, you know that this will cancel out. So directly we are not taking this datum, we are taking this as datum. And what we are measuring, pressure at point number A. Pressure at point A, see, you just think like this, why there is a confusion, I don't know. See, at A point, there is only one liquid is there. You think like this. Height is what? X plus Y, which is a liquid rho m. So what I will write? Everyone know that P1 plus rho 1 g into X plus Y. Second limb, my different second limb is looking like this to me. That is being point B. Till this point, we have the different fluids, which is nothing but this is the fluid rho m, and further in the upward directions we have from here to here we have the y, that is nothing but different fluids rho m, and the pressure I want to measure is P2. So PB, what we can write, P2 plus rho m g into what, y, plus rho m g into what, x, whatever the height is there. That is what I have equated. Check it out. You think like a point number 1 and point number 2, they are being connected to some different pipes. They are belonging to the same pipe, but I'm making you sure that you think like they are connected to the same pipe, different pipes. Is that clear, all of you? Please check it out. Right now, once it is done, let me know. Because who is telling me that dp by dz will be equal to minus of rho g, right? That means in the positive upward directions, my pressure value will decrease. I'm not telling you, hydrostatic law is telling you, right? Even I shown you in this proof also that pressure is equal to what, rho gh in the last class. How it is coming from the Navier-Stokes equation, we have equated the fluid at the rest condition, so acceleration part will be zero. There is no viscosity as the fluid is not moving, so viscous forces will be zero. Ultimately I will be left with only these two terms, pressure forces and the body forces in z directions. Now we will solve the questions, and from the question things will more clarified, I hope so. Let's see. All of you have noted down? Now, see, we will try to solve this particular question. Now tell me whether I should take the reference from here or should I take the reference D and E? Because imaginary this liquid will be what? Same height, they will cancel out. So D and E I will be taking for the reference purpose. D and E. You try to equate my difference. Pressure at point D and pressure at point D. They are asking what is the absolute pressure. What is the absolute pressure of the gas A? Let's say, let's calculate, right? Now, what we can do, pressure at point D, that has to be equal to pressure at point E. What is the pressure at point D? What is the pressure at point D? PA plus what is the height of the liquid till this part? Rho of water G into what is the height? What is the total height? The total height will be 10 plus 5 plus 2 divided by 100. Why divided by 100? Centimeter to meter. You try to convert everything in meter first of all, right? Now, what is the density of this black color which is being shown? Density of the mercury they have given as 13.6 gram per milliliter. So you can convert kilogram per meter cube, right? Now, so rho m into g into this height, that is what equal we have taken, and that has to equal to what? Whatever the height of this liquid, what is that black color is there? Rho m g into height of the that particular fluid, 2 centimeter, 2 divided by 100, plus further we are moving, what we can write, pressure at this point, E point, rho of water g into height. What is that height? Once again 5 centimeters, so divided by 100. Now they are asking me to calculate absolute pressure. Absolute pressure I want to measure, my different. How we can measure? That is a very simple, rho m. Directly I'm writing the rho m value. Sorry, the density value is not 13.6, it is 13,600. So sorry, into 1000 kilogram per meter cube, because when you convert 10 power minus 3, 1 liter is what, again minus 3, so this will be kilogram per meter cube. 1 liter is what? 1 liter will be 10 power minus 3 meter cube. 1 milliliter, once again 10 to the power minus 3 liter. 1 liter, once again 10 power minus 3 meter cube, right? Now, so PA value will be rho m. What is that? 13,600. G value is 9.81, 0.02, plus rho of water is what? 1000, 9.81. This 5 centimeter and this 5 centimeter, like if I subtract it, 0.05 minus this one, what is that? 0.17. So what is the pressure at a point? You just try to calculate 13,600 into 9.81. Keep your calculator on, guys, all of you. 2668.32 minus what I will be getting, 0.05, 0.17 into 1000 into 9.81. I will be getting 1177.2. PA value will be 2668.32 minus this one. So I will be getting the values as 1.1491.12. Just check it out whether it is correct or not. Pascal. Just check it out. Is that correct? No. But that is a gauge pressure. That is a gauge pressure because we have not added till now any atmospheric pressure, right? We have to add the atmospheric pressure to measure the pressure at a point to be called absolute pressure. To be called absolute pressure, I need to add PATM. I need to add PATM. I need to add PATM. What is the pressure at a point? 1.491 kilopascal plus PATM 101.325. So if you just add it, what you gonna get it out? 102. The pressure at point number A, that is the absolute pressure, as 102.816 kilopascal. Check it out. But when you see the option, that is not being given. Clearly, straight away, the options, no option has given us the unit in terms of kilopascal. What we have to do? Again, no need to panic. We know that 101.325 kilopascal, that is equal to 760 mm of Hg. Whatever the height which is being whatever the liquid column of mercury will exert, right, and whatever the height, that is 760 mm of mercury will exert the pressure value, that pressure value will be atmospheric pressure. Sir, how can you say that? You can only calculate 0.76 into 9.81 into 13.6. You only tell me whether you are getting approximately 101.325 kilopascal or not. Mercury, when you just calculate rho gh, that is 13.6 into 9.81 into height 0.76, and that we are calculating in kilopascal, approximately you will be getting this thing. Getting my point? My dear friend, you know that once we have the 101.325 kilopascal, that is equal to 760 of mm of Hg. From our childhood days, we keep on doing this thing. Then 102.816 kilopascal will be how much mm of Hg? You only tell me. That's a very simple, straightforward calculations, whether you're getting E option or not. Check it out. Cross multiply. That's a very simple calculation. Correct. 771.2 will be the approximate answer for absolute pressure. If they would have asked you the values of gauge pressure, then what you would be writing? Tell me, guys, what should be the value? In terms of mm of Hg. In terms of mm of Hg. 11.2. Correct. Correct. 11.2. So 11.2 is a gauge pressure. 11.2, remember, 11.2 is a gauge pressure. But atmospheric pressure is what, my dear friend? 760. So total will be what? 771. That is the total value from our basic zero line, right? 760 was our atmospheric pressure in terms of mm of Hg, and 11.2 is nothing but the gauge pressure, and the total value is what? Absolute only. Now, Now we will try to see some typical one problem where you will be involved. A lot of your headache, you know, might be there when you think deeply about that question. But we have to take that question now. Once it is done, let me know. All of you have noted down. See, guys, these are the very simple thing. You please try to put some effort from your end. After the class, things will become more simplified. You try to solve some single problem based on the no two three problems. You try to solve. Definitely, you will be getting the confident in the particular topic. Right? There is no big issue. Now, all of you done with this? Now, done, done, right? Tell me, guys, please, so that we can solve more number problem. Otherwise, I need to stick to some of the slides only. Now you try to see this question, and again, that is a completely the barometer only, right? Whatever the things they have given, बाद में आता है, whatever the things you have been given here, that is a simple barometer only to measure the atmospheric pressure. But when you try to look at very carefully, right, how they are playing in the gate examinations, right? Sometimes a very simple topic can be a very difficult, like a monster topic. So please try to clear all the fundamental as you can clear as much as you can clear. In the given figure, the pressure of the gas in a bulb A is 50 centimeter mercury. That is being given as vacuum, right? Now, so you consider, see, I told you, you can consider this like a chamber, one chamber, or one pipe. You, even the pipe is not there, you try to imagine hypothetically there is a chamber, and I want to measure the pressure in the chamber, right? So you know that pressure at point number one, here point number one I will take, and pressure at point number two will be same. Everyone know that both are on the same level. So definitely inside the tube I will be taking one point, and outside the tube I will be taking another point, and both the pressure exactly has to be same. Now, pressure at point number one, we know that there is the atmospheric pressure will be acting, no problem at all. Pressure at point two will be what? Rho of mercury G into this height. This particular height will be there, plus pressure in the chamber. Pressure in the chamber. No problem at all till this point. Any confusion? Tell me, guys. Any confusion till this particular point? No. You try understanding what I want to say here. Now, little bit of difficulty might be there, so you try to be ready for that. Now, here I want to measure, for example, my dear friend, if I would be saying to you that pressure in the chamber A is a negative pressure, right? Everyone know that minus 50 centimeter mercury they have given. Now, the pressure value they have given, and you are saying, sir, 50 centimeter mercury, that means height of the mercury column is given indirectly. See, whatever the pressure value is there, that is rho gh. So whether you measure pressure or height, both are of the same unit, right? Means not unit wise, but they are telling you the pressure value. Either you measure height of the column, or you measure directly the pressure value in kilopascal. Both are the more or less will be having same synonyms. Now, what I want to say, that pressure at a point in a chamber they have given minus 50 centimeter mercury. I am telling you, okay, they have given as a vacuum. At a particular point in a chamber, they have given the pressure value it as what the pressure value they have given. The pressure value they have given it as minus 50 centimeter mercury. That 50 centimeter mercury is a what, my dear friend? Tell me, guys. If I want to measure, if I want to measure absolute pressure in a chamber, if see vacuum, vacuum, you guys are not revising the either previous classes, or I don't know what is happening. I already given in the class that one example also. Here, see here, a vacuum gauge is connected at a particular chamber which reads something like that, 5.8. That is a negative word, negative gauge pressure only. It's a vacuum. Please, before coming to my classes, you try to revise multiple time your previous notes. Again, I'm telling you. Getting my point or not, guys? Understanding? Pressure in a particular chamber, if I want to say the total gauge pressure, what is the gauge pressure? That is nothing but minus 50 centimeter mercury, right? And atmospheric pressure, we know that 760 mm or 76 centimeter, both are same thing. 1 centimeter is what? 1 centimeter is what? 10 mm. No problem at all. Now I want to say pressure at a particular chamber. I want to measure absolute pressure. Absolute. If I want to measure absolute pressure in the left side, should I add the atmospheric pressure or should I not add the atmospheric pressure? Tell me, guys. Should I add it or I should avoid it? I should take it zero if I want to measure the gauge pressure. But I cannot take it as zero. I need to add it. You might be having some other value. Let's say height of the liquid is zero here plus PATM you are adding. If you are measuring the absolute pressure, definitely you have to add the PATM. And what is the PATM value? 76 centimeter, right? And what is the height that we have to calculate? H, right? Because we have divided whole term by the rho g, by the rho g, by the rho g, so that we are calculating in terms of that. And what is the chamber value? Minus 50. Sorry. What is that, guys? Now, what is the absolute value? What is the absolute pressure value? You know that absolute pressure cannot be negative. Absolute pressure at a particular point, it cannot be negative, my dear friend. Now tell me what is the positive value? Anyone in the class can tell me what is the absolute value in a particular chamber? Tell me, guys. A very simple calculation. Tell me, not 50. Why 50 you are telling me? That is a vacuum pressure, negative gauge pressure. That is a vacuum pressure, guys. Vacuum pressure, gauge pressure can be positive, can be negative. But I'm asking you absolute pressure. Absolute pressure cannot be negative. It should be more than zero or at least zero. It has to be positive value. And you know that from our simple calculations, if this is my zero level and my level is what? Suppose, for example, my atmospheric pressure is what? For example, 76 centimeter. That is my PATM. At a particular location, my particular value is 50 centimeter. That is a negative. That is a less than PATM. Then what is my absolute pressure? 76 minus 50, 26 centimeter. Either you say at a particular location the value is minus 50, or you say in terms of positive value, what? 26. So what is the height? 50 centimeter only. That is your answer. Either you can think like this, or you can think, or we have second solution also, right? Especially in my classes, you will not be having any single doubt. If you are creating the doubt, unnecessarily you will be creating the doubt from your end. From my end, things will be clarified. How? Let's see. PATM will be rho mercury G into H plus P in a particular chamber. This is a chamber. Let's say the chamber value you want to measure the gauge pressure. Now, if I want to measure the gauge pressure, should I add it atmospheric pressure? No. Suppose we have something in a bracket term plus PATM. I should not add the PATM. I should take it straight away zero, right? So now, if I'm adding what we are measuring the gauge pressure, and you are taking PATM zero. That means this is you are taking to zero. So directly you are measuring what? Minus 50 only. Zero minus 50 plus H. So H will be what? Once again 50 centimeter. So either you calculate in that way or in this way, answer will be same. That is B. Tell me, guys, any confusion? So that's why I told you in a previously only you think like a chamber. Otherwise, you will confuse. You think like a tube which is being inserted to measure some kind of atmospheric pressure, right? Getting my point or not? A very simple calculation I did, guys. Absolute pressure I need to add PATM to some other value of the height. As there is no liquid column height, once again that is 0. Again, there is no liquid column height, that is 0. But if I want to measure the gauge pressure only, I should not add any ATM pressure. First method I told you, right? Absolute C, guys. Absolute pressure. Whether we are adding or not, 8 PATM, you only tell me. Forget about that question. You only tell me if I want to measure absolute pressure, whether we are adding PATM or not. We are adding. Then you only tell me why should I not add it if I want to measure PATM? Why should I not add PATM to the some other term? Is that clear? Now don't think, sir, you always add to the right side. That is a very childhood behavior. Some of you might be thinking, sir, you always add to the right side. See, PA value in a chamber is the left side. We are adding to the right side. Chamber is our my different term is on the right side. Definitely, I need to think about what left whatever the term is there into the what left side. Getting my point or not? Is that clear? Tell me, guys. Is that clear? So I told you pressure. Suppose pressure at Agra or pressure at Bangalore at a particular location, right? They have given as suppose they have given the value as 26 kilopascal. Now tell me at a particular location, whatever the absolute pressure, the total pressure they have given as 26 kilopascal. You only tell me their atmospheric pressure in our Bangalore is 100 kilopascal, and you are measuring only 26 kilopascal. Now tell me there is a vacuum or positive gauge pressure. You only tell me, guys. There is a vacuum. How much of vacuum is there? 74 kilopascal. Negative vacuum is there, right? So I can tell in that way also. Bangalore, there is a minus 74 kilopascal or 74. I can also write 74 kilopascal vacuum like that. We can denote it by two way. One, I can say directly in a Bangalore, the pressure is what? Vacuum 74 kilopascal, or I can say there is a positive pressure, total pressure 26 kilopascal. In both the ways, answer is what? Absolutely same. Whatever the customer is there or to whom you are explaining the Bangalore pressure, he will able to understand. He or she will be able to understand what actually you are trying to say. Getting my point? Even a very small term will play a very vital role in gate examinations. Getting my point? Who knows that this question will be coming in gate 2024 for aero? Who knows that? And who told you that the question cannot be repeated from the other branch? You just go through the previous year question, you will see in solid mechanics and whatever the subject which is being connected to the other branches, you will see here and there the question they are throwing from other branches. Right? Now, once it is done, let me know. So try to understand if I'm putting some effort and some more amount of time on a particular topic, that means that topic is very important. Now, let's discuss one more question so that the things will be clarified regarding this particular topic. Is it done for all? All of you have noted down? Again, do not confuse about this. You are talking in terms of height only. What about the density and G? I have divided whole term by rho G. So I will be getting only H only. So PATM by rho P by rho G is nothing but what? Height of the column. Directly we can write. Because that will give me the height only, right? H. Yeah, pressure value in a particular chamber, they have given minus 50 centimeter mercury. That is either you can write just like that Bangalore I told you minus 74 kilopascal, or in a positive sense you can think like 26 kilopascal. Getting my point? Why we are writing 26? Because absolute pressure cannot be negative. Because directly if you are telling particular chamber pressure is 26 centimeter, indirectly you are telling that there is some vacuum. There is some vacuum of 50 centimeter. Because total pressure, atmospheric pressure is what? 76. and we are measuring only 26 total pressure. That means there is some lagging in the pressure, right? There is a deficit of the pressure value by how much? 50. Now guys, once it is done, let me know. Done. You won't believe, in mechanical they asked this particular question in 2000 years, way back, 23 years no ago. They asked this particular question, but when you look at the once again one more question of the this particular fashion. Yeah. So when you see this mechanical 2020, you know, once again after 20 years, again they tested the whether they know about the concept or not. Same concept, everything is same. Read the problem and tell me the answer. Straight away, without any thinking, even sparing 1 minute of time, anyone in the class can tell me B is correct. The space above the mercury column in a barometer tube, there is a barometer tube which is being connected. Space above the mercury, space above the mercury, right? You can think like chamber one where I need to measure the pressure P, that you can equate pressure at point A, pressure at point B, pressure at A, pressure at B. Pressure at A is what? P atm. Pressure at B will be what? Pressure at B will be what? Pressure at B will be rho of mercury G into H plus PB. PB is what? PB is nothing but vapor pressure. Vapor pressure. They are asking gauge pressure. They are asking the gauge pressure. Whatever the term is there, I need to take it zero. I should not add the PATM. You only tell me that PV gauge pressure value you are getting negative or not. You are getting negative. That's a negative. But if I ask the same question, what is the absolute pressure of vapor? Then what you will write, my dear friend? What is the absolute pressure? Positive, but less than 1 atm, because PV absolute will be P atm minus rho of mercury G into H. More than what? It is a positive value, but less than a P atm. Less than P atm. Right? D will be correct. Right. Now, if it is done, we can move on to the further topic, that is the hydrostatic pressure value. Hydrostatic forces. Once it is done, let me know, guys. Hydrostatic forces on a particular surface which is being submerged either fully or partially onto the particular what? Liquid. Done. Now, guys, so we will see the other topic of that is the hydrostatic forces on a surface which is being immersed in a liquid. Now, guys, before understanding the hydrostatic forces, I would like to tell you multiple fluid system. Now, why I'm telling you? Because I was keep on discussing this topic, multiple fluid system, in a particular tank. In a particular tank, this is a 2D figure, but when you think the 3D figure of that, there is a tank, something like this. In that tank, the liquid height will be there. But not only we have the only one liquid, we can have the multiple liquids also. My defend, what can be happening? In GATE 2023, in mechanical, they have given one question based on the two fluid system. And exactly the same problem, a very similar problem we have discussed in our last year batch. If I show you this particular problem, this one, exactly same one, but slightly changes will be there in the question, but pattern and whatever the procedure is there, exactly the same. They are for 2 marks, right? Now, note down the concept, note, make a note of it. If I want to measure at point number 1, pressure at point number 1, what we can write? What is the total pressure value? First of all, what will be the diagram? If I assume all the densities are all the densities of the fluids to being as constant, then what we can write to my different? Pressure is what? Directly proportional to H. The pressure will be varying with respect to Y in a linear manner. That everyone know that. Then how it will vary? It will vary something like this. That is a linear variation from here, or maybe some different shape may be possible. That depends on the value of the pressure. That depends on the value of the particular pressure. Oh, sorry. That is a particular my different pressure value, as you can observe. That is a linear variations. That is a linear variation. Now, if I want to measure the pressure at point number 1, what we can write? What is the total pressure at point 1? Here, point number, what we say, A, point B, point C, that is equal to 1. So, what is the total pressure? Rho 1 into, let's say this is rho 1, this is rho 2, this is rho 3. So, we can write rho 1 into G into H1 plus rho 2 into G into H2 plus rho 3 into G into what? H3. Now, if I want to measure total pressure, absolute pressure, definitely I need to add PATM, because this is nothing but gauge pressure. And gauge pressure plus PATM, you know that, everyone know that, that is the absolute pressure. Make a note of it. Please make a note of it. Very, very, very important. That depends on the value, right? Guys, it can be like this also. Throughout the height, it can be like this also. H1, H2, H3. But this line, this particular slope value, it can be different also. That depends on the value. Again, I'm telling you, that depends on the value. Free surface symbol is, like a triangle one, something like this. Yeah, will depend on the density as well as the height value also, because that is a product of rho gh. That is a product of rho and h. So what the actually the value you are getting, that will be telling you the value. Whether it will be joining through continuous line or some different slope will be there. Now, can I move to the next segment? Is it done? All of you have noted down pressure distribution. But that is not the correct pressure distribution, guys, because there cannot be zero pressure exactly at the point D. PD, it is looking like a zero pressure, but that is not true. PATM is there, right? So at least we will be having the variation, something like this. PATM will be there, and then the variations can be like this. then the variations can be like this. It depends on the value. Basically I'm drawing in a, whatever the space that is being available right now. Apart from that, PATM will also be there. But generally, my dear friend, whenever we want to measure the hydrostatic forces on a particular wall, this is a wall of that, this is a wall, let's say, of the container. The liquid will exert some kind of pressure forces. Generally, while calculating the hydrostatic forces, we avoid the calculation of PATM. Why? Because PATM is not only acting from here, the PATM is acting from outside also. Whatever the whatever the liquid is there inside, there will be some ATM pressure is there, and outside also on the tank there will be some ATM pressure. They will cancel out. So we will not bother about the PATM hydrostatic forces calculations just because of the atmospheric pressure. Now once it is done, let me know. Done? All of you have noted down? Now guys, so we will discuss about the hydrostatic forces. Correct. Make a note of this particular diagram. As you can see, my different, I have just taken one, I'm just calculating on one side of the ball. See, maybe we have the tank, or we may have, this is a liquid, and in that liquid we might have inserted this one, let's say plate. So definitely onto the plate there will be some hydrostatic forces, and that is what we have to calculate, right? So at a particular, this bottom one, there will be rho gh because of this height of the liquid, plus PATM will also be acting, right? But PATM is not only acting from one side, that is acting from both the sides, so they will cancel out. So we always try to draw the pressure distribution something like this, where there is a no PATM being considered. So make a note of it. While calculating hydrostatic forces on submerged surface, on a submerged surface, because it is being submerged in the liquid, that's why we are calling submerged surface. The atmospheric pressure force the atmospheric pressure can be subtracted. Can be subtracted for simplicity. Right? Very, very important. Even in GATE exam, they have tested this particular, concept of neglecting the PATM. Why? Because if I show you the question, see, everything is important in GATE exam. When you see this GATE is on 18 A paper, consider a cubical tank which is being filled with the water up to the height of 1 meter, assuming the density of the water as 1000, G value as 9.81, the atmospheric pressure value as 100 kilopascal, the net hydrostatic force on the side face of the tank due to air plus water. If you add the whatever the pressure hydrostatic force because of the air plus water, answer is wrong. Because atmospheric air is not only acting on one side, it is acting on both the sides. That is being given for 2 marks. So it's up to you whether you want to neglect that particular topic or not. It's totally depends on the individual candidates whether they want to learn or not that particular concept. So those who are thinking that, even slight confusion is there in your head that sir, it is not that important, I have not learned in BTech any time. In GATE exam, they will not bother about giving these questions. Why they will not bother? Whether you have learned or not, because that is there in the fluid mechanics. That's it. And when you see the syllabus of fluid mechanics, in one line they have finished it for aerospace. And they are asking the question like anything, but while giving in the syllabus, directly they have given in one line. That's it. Either see, again we cannot put completely 100% blame onto them also. Of course we can put them, we can basically put some blame onto them. Why? Because they have to write each and every, just like other branches, what are all the contents are there in the fluid mechanics, even the basic subjects. No, whatever the topic of aerodynamics, complete picture has to be given in the syllabus itself, so that confusion should not be there, right? But what you are observing, that they are asking the question from the other topics also in the fluid statics. Right. Now, some of you might be thinking, sir, what actually here we are looking right now, that pressure value is acting from outside. Why it is acting? Somebody might be thinking, see, you are not particularly sitting in a vacuum room, right? You are sitting in atmospheric conditions. So definitely this particular plate or the liquid where it is there, or whatever the river is there, or whatever the sea is there, definitely that has been surrounded by the what? Earth atmospheric air, So definitely it is acting not only from inside, that is also going to be acting from outside. Now, is it done? Now, so hydrostatic forces calculation we will do. Let me add this slide. Intentionally, I'm moving a little bit slow because this is a fluid static not known to many one, especially being as aerospace background, for that reasons. Now, so hydrostatic forces, guys, there is a, we have to calculate hydrostatic forces. If I just write hydrostatic forces, see there is a liquid, and inside the liquid we have the liquid, right? I'm not bothering till what height it is there. Now maybe liquid height is there, maybe whatever, forget about that. Now there is a some plate is there, that can be vertical plate, that can be inserted, that can be basically immersed. There can be horizontal plate, there can be curved surface also, there can be some curved surface also, right? Of course I'm drawing 2D figure, there might be 3D figure like this, right? Something like that. Now, so definitely there is some hydrostatic forces will be acting throughout this one. And in the strength of material in the solid mechanics, my dear friend, whenever based on the load distribution, we try to pinpoint that exactly where it is acting. Let's say it is a uniformly distributed load. Where exactly the load will be acting? The resultant load exactly at the centroid, right? Let's say the height will be h, exactly at a distance h by 2, it is going to be acting. There's no problem in that. Now, but when we have the uniform varying load kind of thing, and if I'll ask you exactly where the total load will be concentrated, you will be saying exactly, sir, at a distance, let's say the total height is capital H, exactly it is going to focusing at a distance h by 3 from the base, and it is going to be 2h by 3 from a top, center of a particular triangle, right? In a very similar fashion, we will try to see where exactly it is going to be acting, and what is nothing but the formula for hydrostatic forces. So all this pressure force, whatever the variations we have drawn, like this, whatever the variations we have drawn, the resultant force will be acting something like this. The resultant hydrostatic force of all the pressure forces which is being acting throughout the length of the particular object will be what? Let's discuss the formula. The resultant hydrostatic forces will be rho g h bar into area. Make a note of it. Very, very important. Make a note of this one. Now, which area? Which particular area? Which particular area? Which particular area? That is a very, very important. Wetted area. Area of the plate which is being immersed, which is being immersed in a liquid. Or area of the plate or area of the surface which is being contacted with the liquid, which is being contacted with the liquid. Very, very important, guys. Why? Because if I will be telling you one example where you will be shocked to see that there is a plate like this of the capital height h, and the width will be, let's say, for example, the width will be w, for example, and there is a liquid which is being there. Now if it is exerting the pressure force, let's say somewhere here, right? Now what area I need to take, and let's say the height from here to here is small h. I will be telling you each and every term, do not bother about that, right? Now what is the resultant force will be. Now forget about the resultant force, I am just calculating the area. See, guys, area will be weighted area, that is nothing but small h into width. If you are thinking that the total height will be subjected to here it will be subjected to what? PATM. Here also PATM. There is a no liquid column, so that will cancel out. So area, if you are thinking that it should be capital H into W, that is wrong. Make a note of it. Very, very important. So this thing has not been tested in gate mechanical as well as in gate aerospace, but anytime soon that can be tested. Please make a note of it. So my slides are prepared not based on the previous year content or the previous year questions. Slides has been prepared for preparing you for the worst condition or which is going to happen with you the next year, right? So do not neglect even a single line from my slide, especially fluid mechanics and solid mechanics classes. Not a single line or single word from my slide, because because as you can see that the last year batches that definitely when you see that even a single slide questions directly they are given in gate 2023 solid mechanics questions in aerospace. You can check it and verify. You can ask Dinesh sir. He will be sending you that particular slides. I don't know about the other classes, but especially in my classes, if I'm writing row GH, ABCD also, you please write ABCD in your notebook. That will be coming in gate exam. You may be liking it or not, that is a different thing, but definitely that question will be there in gate exam. Now, once it is done, let me know. Now, rho is nothing but the density of the liquid, which is being basically what? Surrounded by that particular plate or a surface. G is nothing but the gravity. H bar is nothing but the what? What is the H bar? Anyone know? The centroidal distance of the plate from a free surface. The centroidal distance of a particular plate from a particular free surface. Now let's see what is the centroidal distance and how to calculate that. Let's focus on that. Yeah. So let me write H bar. Centroidal distance. The centroidal distance of a plate surface from free surface. This is very important word. The centroidal distance of a plate surface from a free surface. So in a very simple calculation, if I'll take one example is there is a liquid column. The liquid is there. The liquid is water, for example, and there is a surface which is being immersed, let's say the vertical rectangular plate. Whose surface is coinciding whose top surface is being coinciding with the free surface, right? This is the free surface. Whenever the triangle symbol is there, that is nothing but free surface. Now, my different try understanding, they want to use to calculate, and the height, total height is being given as capital H, width is 1. We can take 1 unit. If I want to calculate h bar, then what is the h bar? The centroidal distance of a particular plate from a free surface. What is the centroid? Somewhere here in a 2D figure, you will see this is nothing but capital H by 2. This will be your h bar, right? So make a note of it. So the resultant force will be rho of water G, h by 2. Area will be capital H into 1. Right? Let me give one second example so that things will be more clarified. For example, there is a plate which is hinged from here, which is basically hinged from a bottom, right? And there is some gap from a top surface to this one. Same height, same width, I'm assuming as 1 unit, right? So now in this plate, if I want to measure the hydrostatic forces, right, then hydrostatic forces will be rho g into h bar into area. Now what will be my h bar in this one? Centroidal distance of a particular plate from a free surface. What is the centroidal distance, my dear friend? The centroidal distance will be from here to here. Everyone know that it is h by 2. But no, we have to calculate centroidal distance of a particular surface from the free surface. This is my free surface till here. This will be my total h bar. And that will be my capital H by 2 plus x. And once again, area will be capital H into width. Make a note of it. That is a very, very important. All of you have noted down. Can I move to the next one?
Sir, can you explain again the second part?
Second part, see here, whatever the centroidal distance is there. What is the centroidal distance? You know that, right? For a plate, this will be my centroidal distance, right? Getting my point. So, but we have to not take the h bar as centroidal distance from a plate surface. We have to take from a liquid surface. So this h by 2 plus x, both will be added. Getting my point?
Yes, sir, got it, sir.
Now, but where exactly it is acting? That is again one more question. Where exactly it is acting? That is a one more question. Whatever the hydrostatic pressure you are looking right now, where exactly it is acting, my dear friend? Where exactly it is being acting? It is acting at a point we call center of pressure, right? Note down the next concept, center of pressure.
Sir, if a object is like half is immersed in liquid, half is outside, then what is the hydrostatic pressure like? How do we calculate the center in that point?
What?
If
Half
a
of the
body
liquid.
is
Okay.
half is
Uh,
immersed in liquid, half is outside the water
in
space.
that case, again, very simple, right? See, this is the you are talking, right? Half one. exactly half of that, and half is outside, right? Having the width, let's say whatever it may be, W. So you are talking about this case, right? So whatever the liquid is
Yes,
there,
sir.
the liquid will be exerting the pressure force, right? And that pressure force will be rho g into h bar into area, right? H bar will be in that case h by 2 by 2.
Sir, yeah, H bar is
It will
like
be
a
acting centroid of whatever the centroid of that
okay, sir.
plate area which is being immersed in a liquid. Getting my point? And from that centroid to the free surface, as there is a free surface and this middle one is coinciding, this plate, you think this is a plate, you don't think full length is a plate. Now getting my point? So this will be my plate height will be h by 2, and exactly h by 4 distance will be my h bar. Getting my point? Now because on the top of the plate, for the top half of the plate will be subjected to PATM. So that is not being considered, as you know it is being subjected to both the sides. Anyway it will cancel out, and there is a no liquid also, so there is a no liquid pressure force. Now h bar cp will be what? Now first of all note down the definition. The force, hydrostatic force passing through a point, that point is known as that point is known as center of pressure, right? So make a note of it, very very important. A center of pressure, very important. Now center of pressure, if you just think of the formula, so center of pressure formula, h bar cp will be, make a note of it, h bar something like this, where igx is what? Moment of inertia, area moment of inertia, about centroidal axis, right? And my dear friend, what is the h bar? As you know, h bar, what is that h bar? Theta, what is the theta? Tell me guys. The angle by which the top surface of the plate which is being inclined, right? Angle with which the edge of the plate, the top edge of the plate, angle with which the top edge of the plate is inclined in anti-clockwise direction. Very good. So something like this. If there is a surface and I have the plate which is being inclined at an angle theta, so this will be my theta. Now tell me, this will be my resultant hydrostatic forces. This resultant hydrostatic forces will be acting from a free surface at a distance h bar cp. Again, h bar cp also we are calculating from the free surface. Remember that, from a free surface. Very very important. Or you can also write this angle one. That's a very better, because some of you might confuse. Theta will be angle made by surface with the horizontal free surface. We have to measure with the horizontal. Remember that. Horizontal free surface. Because if angle is given as something like this is the plate, angle is given 60, so theta will be 30 degree, for example. In your calculation, theta will be 30 degree. Now tell me, center of pressure will be below the center of gravity, or always coinciding, or above the center of gravity? What we call h bar. H bar Cp will be below that of h bar, or what? From the calculation also you can see h bar Cp will be below of h bar. Now, once it is done, let me know. Once it is done, let me know. My dear friend, you can calculate whatever the pressure force formula is there, whatever the hydrostatic pressure force is there, you can calculate by using the formula that I have given, rho g h bar into area, or you can also calculate by Prisma method, right? Let me write the Prisma method. Further after we can discuss. Now, let me write the, all of you have noted down. So when theta will be 0, in that case, h bar Cp will coincide with the h bar, just like a horizontal plate which is being immersed in a liquid, right? In that case, center of gravity will be exactly on the same height as center of pressure. That is very common sense, right? See, this is a liquid surface and we have the plate. Centroid, whatever the centroid is there, h bar, and where exactly the pressure force will be there, that is also will be acting at a distance h bar Cp. Both will be coinciding when theta will be 0. Horizontal plate. In a vertical plate, theta will be 90 degree. For a particular vertical plate, what we have discussed here, theta is what? Theta we have 90 degree. Done. Can I move to the next segment? Now note down guys, this Prisma method, very, very important. See, whatever you have drawn, 2D figure, till now, whatever you have drawn, this is a plate which is being immersed in a liquid, and there's a ATM pressure will be there. Let's suppose there is a liquid and there is a variation of pressure will be something like this. That is a 2D figure. In a 3D figure, you will be getting prisma only, See that. See that here, when you look at from here, there is a width of the plate. Whole width of the plate will be subjected to what? Hydrostatic pressure force, hydrostatic pressure value, right? And when you draw that, here PATM is there. From here to here, there is a PATM. Here to here, there is a total pressure. What is that? Rho G, whatever the height is there, whatever the height of the liquid from here to here, let's say from here to here, H plus PATM. So when you draw that line from here to here, you will be getting something like this. Now, if I'll be asking you, what is the pressure force? You know the formula. What is the formula, sir? Tell me, guys. What is the formula? Or B is given. Let's say from a free surface, this height from the top edge, let's say this is nothing but small h. Let me write this to be capital H, or we can write small h plus P. Now tell me guys, what is the force formula? Hydrostatic resultant force. Rho G H bar into area. Rho we know, G we know, H bar is what? H bar will be what? From a centroidal distance, from here to here it is B by 2, but centroidal distance to the free surface, that will be my H bar. And that height will be B by 2 plus small h. into area. What is that area, my dear friend? Can I say B into A? Can I say B into A? This is the area of the plate on which this is acting, right? B into A. Getting my point? Yeah. So this is the formula wise method, right? This is the formula method. But sir, I want to calculate by prism method. Directly, whatever the resultant force is there, volume of the prism. You draw the volume, you draw the prism, and whatever the volume is there, right? That volume will be resultant force. Sir, how you can say that? We can say very comfortably. Why? Let's see. Now you try understanding. I want to say here the volume. Volume will be what? This is a volume. I can this particular prism is made up of two things. One this one, and second is this one. You try to calculate volume one and volume two. Volume one plus volume two. Neglect the ATM pressure. Neglect the ATM pressure, or if you just consider the ATM pressure also, then what you can write, my dear friend? Tell me, guys, what you can write? What is this pressure? How to calculate the volume of the prism 1? What will be the volume of the prism 1? Tell me, guys. Sorry, this will be not PATM. This will be rho g into H. What is the total volume of this prism? Separately, you just draw the diagram. Separately, you draw the diagram. This is my first one, right? Here, the what is the value of the pressure? Everyone know that this is the height H, right? So sorry, this is not the height H. This is the height B. This is the height B, and this is nothing but rho g into H, right? This is the pressure value which is acting. See that rho g H. See guys, on this one, this is what is the value from a top surface? What is the total pressure? The total pressure will be rho g into H. That is the pressure value will be acting rho g H. And what is this one? B is there, and what is the width? Width will be A. Then what is the volume of the prism one? What is the volume of the prism one, guys? Rho g H into AB. Getting my point? So this will be I'm writing rho g H into AB. What is the volume of the second prism, guys? Extra pressure, whatever is there at the bottom, that is being coming because of this height further. B height, rho g into B. Then what we can write, my dear friend? What we can write over here? What we can write? Rho g into B, B into A. Then how to calculate volume of this particular prism? Half of base into height into this one. Perpendicular dimensions. Rho g into B, rho g into B into B into A. So what is the total value? Rho g H into AB plus half of rho g B into B into this. So what I will be getting? Rho g into B into A into B. So what we can write, my different? Rho g into BA we can take outside. So we can write H plus B by 2. Now what you are observing from here, this particular formula and this formula, this resultant force, both are same. Now some of you might be thinking, sir, whenever we calculate the volume, sir, we always write meter cube, right? But here you don't get the meter cube. Any cubical element you will take, any cubical element, A, B, H. What you used to write volume? A, B, H. Here, my dear friend, the volume is made up of pressure value, At the bottom, there will be some pressure value, rho g H. What is the unit? Newton per meter square. What is the dimension of B? Once again, meter. What is the dimension of A? Once again, meter. They will cancel out. They will give you the unit of Newton only. That's why the volume of the prism directly will give you the resultant force. Make a note of it. Dimensions of the sides of a particular prism. will give you the forces value. Getting my point? You don't think, sir, there is a no dimension horizontal. Instead of taking the dimension as c, you think like c is nothing but rho gh only. Getting my point? And remaining dimensions will be as exactly we have to write. Now, why I'm telling you this method? Because whatever the problem they have asked in GATE 2023 mechanical for 2 marks, you can very easily attempt that question by prism method. Moreover, this formula is not applicable for multiple fluid system. Not for multi-fluid system. That means whenever you have only single liquid column, then only you can use it, this particular formula. When you have the multiple fluids, then definitely you cannot use this particular formula. Remember that. Either you want to convert other liquid into in terms of single liquid column, then you can use it, or you better use the prisma method. So in short, I can write prisma method good for multiple fluid system. Let me show you one example. Let me show you one clear example, as you can see here. Here, this tank is being subjected to liquid this one and water this one. Now, if I'll be asking you what is the total pressure force on this side of the tank, definitely you cannot calculate just with the help of directly sir rho g h bar into area. That will give you the wrong answer. For that, you need to convert either whatever the liquid of specific gravity pointed totally in terms of only water column, and then you can use it that particular value. But in that case also there is a one conditions. When you want to use this formula, you can convert all the multiple fluids into single fluid system. You can convert, but what the problem will be arises when the plate or a particular liquid is full of depth of the liquid. That means when the tank is completely filled, something like this, maybe some other liquid is there up to the height h1, and up to this one there is some other liquid rho 2 rho 1. Now the liquid is completely filled till the top one. Now if you want to reduce rho 2 in terms of rho 1, maybe if you just convert into single liquid column height, then what will happen? Your liquid level will come down. Means if you just convert, I will tell you the method of that, no need to worry. Let's say this is the capital H. Now we are converting into single liquid column. But what will happen? The pattern of the problem or original problem will change. Now the complete height of the surface will not be subjected to liquid pressure. As you can see, this part has been left out. So what is again, there is a one more limitation to use that or to convert into to convert the multiple fluid system into single fluid system when the surface is not fully subjected to liquid column. When the surface is not fully subjected to liquid column. Getting my point? Yes, 1 meter will change to 0.8 meter, right? And in this particular case, my different the problem statement will change. Till now, this part of the height of the surface is being subjected to complete 1.5 meter is being subjected to water pressure. But when you convert into single water column height, only how much will be there? 0.5 plus 0.8. 1.3 meter height of the surface will be subjected to water force, and that is not the accurate way of that. What about the extra portion which is being left out? Initially it was being subjected to liquid column pressure, right? But now it is being subjected to what? Change one. You can use the multiple fluid system when you are having multiple fluid system rho 1 rho 2, but the plate is like this, for example, and now you want to calculate. It's a very easy one. Even though you change it, right, the total height may be converted to some other height. Let's say here, let's say it is being subjected to let's say rho 2 only. even the total height is being reduced, but it is still more than this plate height, let's say. So again, the problem statement will not be changed, right? Now, so that is a different matter of concern, but as of now, we want to solve the problem. Let's focus on the particular problem. All of you have noted down this segment. Is it done? No. Forget about, we cannot convert whatever this for I have given, right? 1.5 and 1.3. That is absolutely wrong. Rho g h bar formula is not at all applicable there. Whether you convert to single fluid system or a you in any way you cannot use it to two fluid system, right? You will convert 1.3 meter. Again, you cannot use it. The Rho g h bar formula. You have to use there in that statement, in that question, prism method. Now, try to solve this question and let me know the answer. For simplicity, let me draw the figure so that some of you might not confuse by this statement. Only thing you have to do, in especially the subject which is being taken by me, is practice from your end. In a particular class, I cannot discuss 50 or 100 problems regarding single topic. I'm covering as maximum as possible, and different variety of the problem. The rest is your effort. If you're not practicing, definitely after my discussion also, you may not be able to solve gate problem next year. I'm telling you, just because of the lack of practice, right? Don't think that whatever I'm covering is sufficient. No, I'm telling you it is not sufficient. You have to practice a lot regarding the numerical part. There is a cubical tank. This cubical tank, which is being subjected to the liquid pressure. Now, when you try to see here from this one, the total height of the liquid or the tank side is nothing but 2 meter, but the liquid is being filled up to the height of 2 meter. Oh, sorry, 1 meter. 1 meter. Now, my dear friend, I want to calculate the net hydrostatic force on the side face. Any side face you can take. This is the one side, this is the second side, third side, fourth side. Any side you can take. I'm taking one second side. For example, what is my net hydrostatic force onto this side, which is having 2 meter side? This side I'm taking, and the liquid surface is something like this. Now I want to measure the hydrostatic force. What is the hydrostatic force? Rho g h bar into area. Rho is what? 9.81. Density I'm taking, yes, again I'm taking the density as 1000. H bar is what? The centroidal distance of a particular surface of a plate from a free surface. The centroidal distance is what? This is a 1 meter, and the centroidal distance will be 0.5 meter from here to here, and that is what exactly coinciding with the free surface. So that is 0.5 meter. Area of the plate which is being subjected to fluid pressure. What is that area? 1 into 2 meter. This is the area, right, which is being subjected to liquid pressure. 1 into 2. So when you calculate, you will be getting 9.81 into 1000 Newton. When you convert in kilonewton, you will be getting 9.81 kilonewton. Do not think about the air pressure, because that air pressure from here to here will be not only from here, will be from outside also. They will cancel out. And don't think that this will be this side of the plate or tank will be subjected to any kind of pressure. Why? Because this side of the tank is being subjected to only ATM pressure from both the sides. Now, my always intention of discussing the problem See, you might be thinking, sir, you are solving the problem in more than 3 minutes, and you are expecting from me to solve the problem in 3 minutes of time during the gate examination. There is a reason for that. I used to discuss the whole dimension of a particular problem, even though it is taking time. Let it be. But if I discuss the all the other dimensions of a particular problem, so that you will not struggle, right? When you're solving any textbook problem or any problem, you will not struggle there, because you will know that basic concept, you will know the fundamental thing. Quickly you will be able to solve without wasting further times, right? Instead of discussing in that way, if I discuss the problem, okay, this is a shortcut, you try to use it, get the answer in 2 minutes, done, dusted. What is the use of that when you are struggling again at your home while doing the problem? Getting my point? Understanding or not, guys? Once it is done, let me know. Can I move to the next problem? Again, this is a very good problem. We will discuss. This one I will discuss. This is also one of the good problem. Now you try to solve this one, and now tell me the answer, anyone. I'm giving you the time. Just this is the last problem. Then I will discuss the remaining problem in the next class. Tell me the answer for this. G value they have given as 10. They are asking what is the force exerted by the water onto the plate. This is a plate, right? They are not asking on the vertical walls. They are asking onto the plate, right? So think like that. The plate dimensions they have given as 2 meter, 2 meter. That is a square, a square cross sections. What is the force which is being exerted? Rho g h bar into area. Rho is what? Newton. We have to convert in kilonewton. So let me write fully. Rho 9.8. Sorry, that is h bar will be from here to here. What is that? 1 meter. And once again we have to calculate from here to centroidal distance from CG to top surface, that is my h bar. So 2 plus 1, that is equal to 3. Area of the vertical plate which is being subjected to water force, 2 into 2. 1000 into 10 into 3 into 4. So 120 into 1000, that is Newton, 120 kilonewton. Make a note of it. Once it is done, let me know. So once I will upload this slide, try to solve the remaining problem. Anyway, we will discuss in the next class also. Apart from discussing the fluid kinematics, that I will start the next chapter. Done? All of you have noted down? Now, try to solve this particular problem as a homework and try to see this one. Try to solve this particular problem and note down the answers. They are asking force exerted by the on the plate by the reach. This is the ridge. What is the force which is being exerted by this ridge? They are asking. So 442.81 kilonewton. That is the force exerted by the ridge. Right. So you try to solve. I will discuss if you are not getting. So that is a very good concept, right? Of engineering mechanics. A hint I can give that there is a hinge point over here. So summation of moment about A has to be 0. So one force of the ridge. Other force is hydrostatic force. Both you try to balance and let me know the answers. From here to here exactly, H was Cp, it will be acting. Correct. Now you try to solve and let me know the answer, right? I already given the answers. Let's see whether you are getting or not. Done? All of you have taken this one? Once it is done, you can leave for the day. Thank you all.
Sir,
Yeah.
can you move to the prism slide, like that slide?
Yes.
Sir, in the volume of the prism method, like volume method, volume 1 and volume 2, this H is H bar, right?
No, volume of the prism means dimensions of the prism. Here dimension is what?
Not
As you
this
can
one,
see,
sir. Other one, like a small one, FR equals to for volume of the prism. Volume 1 plus
yeah, that is
volume 2.
what volume one will be. Volume of the
This
prism one will be dimensions, right? A, B, C. A, B, C is what? Rho G H. Right?
this H is H bar, or this H is the
No,
height
no, no,
of the
no.
prism?
Height of the prism. That's height
Okay,
of the prism.
that's
Thank you all.